Hello, I'm Markus Berchtold from company RUMUL. We are making resonant fatigue testing machines which are suitable to make crack propagation tests on high testing frequency, as for example 80 Hertz. Today I would like to show you how to set up such a test with a CT-specimen, which is already installed here. It's made of aluminium. The COD gauge is clamped to the specimen with additional knives. It's our own product that is measuring the crack opening, and based on the crack opening, then the crack length is calculated by the software as described in the ASTM E647 standard. The machine has a dynamic drive that is placed on the top, driven with a magnet. So the upper part is the oscillating head, and the table is the countermass of the machine. And the machine always runs then exactly in the resonant frequency. For installing the specimen, I used this remote control with a touch screen. This allows me also now to check how good the test setup is running, which this is critical. This is very important, otherwise you are not able to do such a test. For measuring the crack length with the gauge, everything must run perfectly. I could also check the load signal with this remote control. This looks quite nice. So, having everything installed, I would like to show you now the software, how to start such a test. I stop the machine again. First thing is to tell the software which kind of sample that I have, the size, the crack length that is actually present, and the software allows me to define the formula how the delta K is calculated based on the force and the specimen geometry, including the crack length, which I have to say the software how this crack length shall be calculated. As a default, you have here the formula from the ASTM standard. I have to tell the software how to measure the crack length. The compliance method is the one we are using now with the clip on the probe, and here as well I can tell the software the formula how the crack length is calculated based on the ECB. This is the normalized function of crack opening versus force. Here we see as well as default the formula from the ASTM standard. I can also define some filter to improve the quality of the measurement, and I can average the so-called ECB, this normalized function. I have selected here 30, so it takes the average of 30 measurements. Important is also to tell the software the Young's modulus. It's an aluminium specimen, so this is already defined here. Then in the next step I can select the testing mode. For starting, I'm using constant delta K, or I could also use constant delta force. To have a constant stress intensity factor for creating the pre-crack, I select constant delta K, and I can select here delta K to start the crack with a defined load ratio, the R value, upper load, lower load versus upper load. And the increment that is here is the change in crack length to calculate the crack growth, DADN. After every 0.1 millimeter it is calculated newly. So, having done this, I'm starting the test now. First applying the static load, and then select all the signals I would like to record. Then I start. Now the testing machine is searching the frequency with a sweep. Once it found the resonant frequency, it's loading up. It needs a little bit time to stabilize. Once it runs stable, it does calculate the crack length, and this is done based on the compliance. It's force versus strain, which we see here. Based on these slopes, the ECB is calculated, and then the crack length. Here I can also increase the number of periods that shall be used for calculating the slope here. So now I have selected 20 cycles, 20 load cycles are used now to calculate this slope. This does also average the ECB. And I can define the borders, the limits within the slope is evaluated. This looks okay now. A good indication is also the correlation. This is the correlation of the slope. The more niner, the better. So this looks quite good. The most reliable system, but however, to see if a crack is growing, is the change of the testing frequency. As we see here, it is already running. The frequency is going down slowly, and also the crack length measurement is increasing, so everything is consistent. So to create now the pre-crack, I tell the software then to stop once now the fatigue crack, once this fatigue crack has reached 2 millimeters. So, and after that we will then change the testing mode to decreasing the load, the stress intensity, to determine finally the threshold. Alright, this will show you in the next video.